Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to learn about coding and decoding, which has a weightage of about 3 to 8 marks in various competitive exams. Coding and decoding is all about sending some information in a coded form such that only the desired person can decode that information and understand what information has been sent. We can get various types of questions from coding and decoding as the logics of coding the information are infinite. So let us first discuss some very popular logics from this topic and then we shall move ahead with different examples. Let us now look at the various ways of coding the word bank. If you take the first example here, the word bank has been coded as $$% That means the complete word here is represented with the help of various symbols. Now the simple logic here is each letter is represented by a particular symbol and that has to be considered as the coded form for the given letter. For example, the letter B is taken as $, A is taken as hash, N is taken as $, and K is taken as percentage. So once we get to know the coded form of each of these letters, we can find out the code for any other given word. Let us now look at the second way of coding here. The word bank has been taken as CBOL, which means B is taken as C, A is taken as B, N is taken as O, and the letter K is taken as L. The logic behind this kind of coding is shifting of the letters either in the forward direction or in the backward direction. If you observe here, each letter in the word bank has been shifted by one position in the forward direction. For example, the letter which comes after B is C. The letter which comes after A is B. After N, O. After K, we have L in the alphabetical order. So that is how each letter has been shifted by one position as per the alphabetical order. So we can say that the coded form of the word bank here is +1. That is the logic behind this coding is +1. So each letter has to be shifted by one position in the forward direction. Similarly, each letter can be shifted by 2 positions or 3 positions for that matter. Let us now take the third one. Here the word bank has been taken as AZMJ. That means the letter B becomes A becomes Z, N becomes M, and K becomes J. Now the third coded form here is similar to the second one, but the only difference here is shifting has been done in the backward direction. For example, as per the alphabetical order, the letter which comes before B is A. If you go in the cyclic manner, the letter which comes before A is Z. The letter which comes before N is M, and the letter which comes before K is J. So as per the alphabetical order, each letter here has been shifted by one position in the backward direction. So I can say that the logic in this coding is -1. That is shifting each letter by one position in the backward direction. Similarly, the letters can be shifted by 2 positions or 3 positions in the backward direction. Now the next one here is ABML. The word bank is taken as ABML. That is B is equal to A is equal to B, N is equal to M, and K is equal to L. Even in this form of coding, the letters have been shifted, but some of them have been taken in the forward direction and the others have been taken in the backward direction. If you observe, B is taken as A. That means it is shifted by one position in the backward direction. The letter which comes before B is A. If you go to the second position, the letter which comes after A is B. That means the second letter has been shifted in the forward direction. Again, the third letter N has been shifted in the backward direction because the letter which comes before N is M. And moving on to the fourth letter, K has been taken as L. That means it has been shifted in the forward direction. So we can understand that the letters of the word bank have been shifted here, but in alternate ways. That means the first letter is shifted in backward direction, second in the forward direction, third in the backward direction, and again fourth in the forward direction. So we can say that this type of coding is in the alternate shifting form. So first letter is taken in backward, second one in forward, third one in backward, and fourth one again in the forward direction. So we can take it as -1 +1 -1 +1 and so on. Similarly, the other way of coding in this form could be +2 -2 +2 -2, or plus 3 minus 3 plus 3 minus 3 and so on. So we need to identify the logic based on the shifting of these letters either in the forward direction or in the backward direction. Now moving on to the next one here, the word bank has been taken as CCQO. Again in this case as well, the letters of the word bank have been changed to some other letters in the alphabetical order. Now the logic here can be understood by finding out the shift of each letter in the coded form. For example, the letter B is taken as C. That means it has been shifted by one position in the forward direction. So we can say that this is plus 1. If we move to the second letter A, it has been taken as C in the coded form. And the distance between A and C is 2. That means the letter A is shifted by 2 positions in the forward direction. So we can say that the C here in the coded form is 2 places away from A. Moving on to the third letter N, it has been taken as Q. And if you go by the alphabetical order, Q comes 3 places after N. That is N, O, P, Q. So we can say that Q is a result of shifting N by 3 positions in the forward direction. Similarly, the letter K has been taken as O. And if you try to find out the distance between K and O, it comes out to be 4 positions. That is K, L, M, N, O. So it is very clear that K has been shifted by 4 positions in the forward direction. So the letter O is a result of shifting K by 4 positions. So if you observe here, the pattern is plus 1, plus 2, plus 3 and plus 4. That means each letter here has been shifted by some positions in an increasing order. So friends, if you try to observe, the word bank has been coded in various ways in these 4 models. And the logic behind this coding is only the shifting of letters in different patterns. For example, in the first one, each letter was shifted by 1 position in the forward direction. In this one, each letter was shifted by 1 position in the backward direction. In the third case, they were shifted in an alternate manner. That means the first letter, third letter and fifth letter were shifted in backward direction, and the second, fourth and so on were shifted in the forward direction. And if we take the last one, there is a pattern in the shifting of the letters. That is, it is an increasing pattern, plus 1, plus 2, plus 3, plus 4 and so on. So this is how we are supposed to understand the logic behind the coding of the given word. Friends, remember that these are only some of the ways of coding the word bank. As I've already mentioned, there are infinite ways of coding a particular word. It is all based on the perception. So we just need to identify how the letters have been shifted by trying out the various things. There is no particular formula or method to find out the exact coding. It is all based on trial and error. So we simply need to check in different ways and identify the correct logic. Let us now look at some other ways of coding the word bank. Now if we take the first case here, the word bank has been taken as 211, 411. The logic in the first type of coding here is based on the positions of these letters as per the alphabetical order. If we try to assign each of the letters of the English alphabet with their positions in the alphabetical order, we can understand that the letter A is going to take the first position, B will be in the second position, C takes the third position and so on, and finally Z will become the 26th letter. So the logic behind this coding is based on that kind of positioning. For example, we know that B is the second letter of the English alphabet. So that is how we have got 2 in the first place. A is the first letter of the alphabet. So the one which is there in the coded form is the result of the position of A. The letter N will be 14th letter of the English alphabet. So that is how we have got the next number 14 here. And finally the letter K is the 11th letter of the alphabet. So that is how we have got 11 in the last position. So we can say that the word bank can be taken as 211, 411, where 2 corresponds to the position of B, 1 corresponds to the position of A, 14 corresponds to the position of N, and 11 is the position of K in the English alphabet. So to understand these kind of logics, it is very important that we remember the position of all the letters as per the English alphabet. And to do that, you simply write down all the letters and their positions and try to mug it up. Let us now understand the coding behind the second one. Here the word bank has been taken as 25261316. Now, what could be the reason behind this kind of coding? The logic is, here the positions have been taken in the reverse alphabetical order. For example, as already discussed, when we write A to Z in the alphabetical order, A becomes the first letter, B is the second letter, C is the third letter, and so on till Z is the 26th letter. But if we take the positions in the reverse order, Z is the first letter, Y is second letter, X is the third letter, and so on till A becomes the 26th letter. So here the coding has been done based on the positions of these letters in the reverse alphabetical order. So if we try to write down the positions in reverse order, we come to know that B will be the 25th letter. So that is how we have got 25 in the coded form. A is going to be the 26th letter, as it is the last letter in the reverse order. N will be the 13th letter, and K is going to be the 16th letter in the reverse order. So the other way of coding the word bank here is taking the positions in the reverse order. Now these two models are quite opposite to each other, because in the first case we have taken the positions in the alphabetical order, and in the second case we have taken the positions of the letters in the reverse alphabetical order. So it is very important that we remember the positions of the letters as per the alphabetical order. Let me now explain one simple way of remembering the positions of the letters in the reverse alphabetical order. Assuming that we know all the positions as per the alphabetical order, the positions in the reverse order can be simply understood by a simple formula. In ranking, we have learned that whenever we know the position of one of the persons from one end, we can find out the position from the other end by a simple formula. That formula is total number of persons minus the position from one end plus 1. That means if you know the position from one end, the position from the other end can be taken as total number of persons minus position from the given end plus 1. So with the help of this formula, we can always find out the position of the letters in the reverse order. Assuming that you know the positions of the letters in the alphabetical order, let us see how can this formula give us the positions in the reverse alphabetical order. For example, let us start with the letter A. We know that A is the first letter in the alphabetical order. So in the reverse alphabetical order, its position can be taken as T minus P plus 1, where T is total number of letters, that is 26, minus P. P is the position in the alphabetical order, that is 1 plus 1, and this is equal to 26. So we can say that the position of A in the reverse order, let us take it as A dash, is going to be 26. Similarly, if we move on to B, the position of B will be equal to total letters, that is 26, minus the position in the forward direction, which is 2 plus 1, and this comes out to be 25. Let us take the letter O. The position of O in the reverse order can be taken as total letters 26 minus, we have to remember the position in the forward direction, and the position of O in the forward direction is 15 plus 1. So the position of O can be taken as 26 minus 15, that is 11 plus 1, 12. So O will be 12th letter in the reverse alphabetical order. Let us take another example, the position of R in the reverse direction. So it can be taken as 26 minus, the letter R is 18th in the alphabetical order, plus 1. So 26 minus 18 is 8, plus 1 gives you 9. So we can say that the position of R in the reverse order is 9. So that's how it is very easy to find out the position in the reverse order once we know the positions of the letters in the alphabetical order. So if we look at the word bank here, we already know that B is 25 and A is 26. Now the letter N is 14th in the alphabetical order. So in the reverse order, it is going to be 26 minus 14 plus 1, and that will be equal to 13. So its position in the reverse order will be 26 minus 11 plus 1, and that is going to be 16. So that's how we can very easily find out the positions of the given word in the reverse order. And it is very easy to understand this once we know the positions as per the correct alphabetical order. Let us now take the next one. Here the word bank has been taken as YZMP. Now the logic in this type of coding is as follows. We know that the letter B is second in the alphabetical order. But when we come from the reverse side, that is in the reverse alphabetical order, the same second position will be occupied by the letter Y. So that is why B has been replaced with the letter Y. So B is second letter in the alphabetical order and Y is second letter in the reverse alphabetical order. Similarly, A is first letter in the alphabetical order, and when we come from the reverse side, Z is going to be the first letter in the reverse alphabetical order. And moving on to N is 14th in alphabetical order, and the 14th letter in the reverse alphabetical order will be M. And similarly, K is 11th letter in the alphabetical order. So from the reverse side, P is going to take the 11th position. So that's how we get the coded form of bank as YZMP, by taking the letters of same positions from the reverse side. So we can say that the logic here is the letters from reverse direction. Before we move to the next model, let us understand how to find out the letter which comes in position of these letters from the reverse side. Let's take the letter N. We know that in the alphabetical order, N takes 14th position. Now to find out what letter is going to come in 14th place from the reverse alphabetical order, what we can do is, first of all, find out the position of N from the reverse side. And that can be done with the help of this formula, as we have already discussed. So we can say that the position of N in the reverse side will be 26 minus 14 plus 1. That is total number of letters minus position in the alphabetical order plus 1, which comes out to be 13. So we can say that N from the reverse side is going to be 13th letter. Now to find out the letter which comes in place of N in the reverse direction, we can simply take the 13th letter which comes from the alphabetical order, that is in the forward direction. And we know that the 13th letter from the forward direction is M. The letter N here is replaced with M. Let us do the same thing for the letter K. We know that K is 11th letter in the alphabetical order. So from the reverse alphabetical order, the position of K will be 26 minus 11 plus 1. And that comes out to be 16. So we can say that the letter which comes in place of K from the reverse alphabetical order will be nothing but the 16th letter in the alphabetical order. And we know that the 16th letter in the alphabetical order is P. So that's how the letter K here is replaced with P. So from these two examples, you can understand that it is easy to find out the position in the reverse direction as well as the letter which comes in the same position in the reverse direction, if and only if we are perfect with the positions in the alphabetical order. So the immediate thing which you all need to do here is write down all the letters and mug up the positions of these letters as per the alphabetical order. And with the help of this formula, we can find out the reverse positions and the letters which come in the reverse position. Let us now take the next one. Here the word bank has been coded as 28. That means the 4-lettered word bank has now become a 2-digit number 28. The logic in this coding is the sum of the positions of the given letters. We know that B is second letter in the alphabetical order. A is first letter in the alphabetical order. N is 14th letter and K is the 11th letter. If we add up all these positions, we come up with the result 28. 2 plus 1 is 3, plus 14 is 17, plus 11 is 28. And that's how the word bank has been coded in this case. That is simply the sum of the positions of these letters in the alphabetical order. So here the logic is sum of the positions. Let us now take the next one. Here the word bank has been coded as 308. That means the 4-lettered word now has become a 3-digit number, that is 308. The logic in this coding is the product of the positions of the letters of the word bank. So instead of taking sum of the positions, when we multiply all these positions, we come up with 308. That is 2 into 1 into 14 into 11. That is equal to 308. So that's how we have got the coded form 308 for the word bank. So here we can say that the logic is product of the positions. And let us now look at the last case here. In this case, the word bank has been coded as a single digit number 7. The logic in this coding is the average of the positions of the letters of the word bank. We know that average is nothing but sum of all the elements by the number of elements. We have already found the sum of the positions of the letters of the word bank, that is 28. Now when we take the average of these positions, it will be equal to 28 by 4, as there are 4 letters in the given word, and that is equal to 7. So that's how we have obtained the coded form 7 for the word bank. So we can say that the logic here is average of the positions. So if you observe, in the last 3 models, we have performed some or the other arithmetic operation on the positions of the letters B, A and K. In the first case, it is sum of the positions. In the second case, it is a product of the positions. And in the third case, it is average of the positions. If you observe, all the coded forms on the right hand side are only based on the positions of the letters B, A and K. In the first case, it is the positions in the alphabetical order. In the second case, it is the positions in the reverse alphabetical order. In the third case, the letters have been replaced with those letters which come in the same position in the reverse alphabetical order. Next one is sum of the positions. This is the product of the positions, and the last one here is the average of the positions. So from this, it is very clear that we should be perfect with the positions of all the letters, so that we can crack these kind of logics. Let us now take some examples based on the various logics that we have discussed just now.